Non-metallic sheath cable, often referred to as NM cable, is commonly used for electrical wiring in residential and some commercial buildings. However, its use in temporary electrical systems on construction sites, particularly in Type 1 or Type 2 structures, requires careful consideration and adherence to the National Electrical Code, or NEC. The NEC outlines specific requirements for temporary wiring installations to ensure the safety of workers and prevent electrical hazards. This oration will address several key aspects of NM cable usage in such settings, focusing on the NEC requirements, methods for protecting the cable from damage, splicing techniques, and general safety measures. Firstly, let's address the use of NM cable in Type 1 or Type 2 structures. The NEC permits the use of NM cable in multifamily dwellings and other structures of Types 3, 4, and 5 construction. However, Type 1 and Type 2 structures have stricter requirements due to their fire-resistant construction. Therefore, NM cable, which is not as fire-resistant as other wiring methods, is generally not permitted for temporary electrical systems in these types of structures. It is imperative to adhere to this restriction to maintain compliance with the NEC and ensure the safety of the construction site. Secondly, protecting NM cable from damage is a critical concern on construction sites. The nature of construction work involves various hazards, including scissor lifts, metal studs, HVAC systems, and the constant movement of materials and equipment. These factors can easily damage NM cable if it is not properly protected. The NEC mandates that temporary wiring be protected from physical damage. Several methods can be employed to achieve this. One approach is to secure the cable using approved cable ties, straps, or hangers. These fittings should be installed at appropriate intervals to prevent the cable from sagging or coming into contact with potentially damaging objects. The NEC specifies that non-metallic sheath cable shall be secured by staples, cable ties, straps, hangers, or similar fittings designed and installed so as not to damage the cable at intervals not exceeding 1.4 meters, which is about 4.5 feet, and within 300 millimeters, or about 12 inches, of every cabinet, box, or fitting. Another important measure is to ensure that the cable is not subjected to excessive bending or pulling. Sharp bends can damage the insulation and conductors, leading to electrical faults. Similarly, excessive pulling can strain the cable and weaken its connections. To prevent these issues, the cable should be installed with sufficient slack and supported properly at regular intervals. In areas where the cable is particularly vulnerable to damage, such as where it passes through metal studs or other sharp objects, metal plates or other protective covers should be used. These covers provide a physical barrier that prevents the cable from being punctured or cut. Additionally, elevating the cable above the ground level can help to prevent damage from foot traffic, equipment, and other hazards. By keeping the cable out of the way of these potential sources of damage, the risk of electrical faults and injuries can be significantly reduced. Thirdly, the application of NEC Section 334.30, which deals with securing and supporting non-metallic sheath cable to temporary NM cable installations in construction, is a common point of confusion. While Section 334.30 specifically addresses permanent wiring installations, its principles can be applied to temporary installations as well. The NEC states that except as specifically modified in the article on temporary wiring, all other requirements of the code for permanent wiring shall apply to temporary wiring installations. This means that the general guidelines for securing and supporting NM cable should be followed in temporary installations to the extent practicable. Although Section 334.30 does not explicitly apply to temporary NM cable installations, it is generally recommended to provide adequate support for the cable to prevent damage. The recommended support intervals of approximately 4.5 feet to 10 feet are reasonable for temporary installations, as they provide sufficient support without being overly restrictive. Now let's discuss splicers without boxes. The NEC permits splicers without boxes on construction sites for multi-conductor cord or cable assemblies, provided that grounding continuity is maintained. This exception is intended to simplify temporary wiring installations and reduce the amount of material required. However, it is crucial to maintain the outer sheathing of the cable after making the splice to prevent exposure of conductors. When a box is not used and the outer sheathing is stripped back, the splice must be made in a way that ensures the conductors are properly insulated and protected from physical damage. Wire nuts can be used for the splice, but additional protection, such as electrical tape or shrink tubing, should be used to secure the splice and maintain the integrity of the outer sheathing. The goal is to create a splice that is as safe and reliable as if it were contained within a junction box. It is essential to ensure that the grounding continuity is maintained throughout the temporary wiring system. This means that all metal parts of the system, including enclosures, equipment, and grounding conductors, must be properly connected to a grounding electrode. This is essential for providing a low impedance path for fault current, which helps to protect workers from electric shock and minimize the risk of fire. Finally, in addition to the technical requirements, several general safety measures are crucial for ensuring the safety of workers on construction sites. One of the most important measures is the use of proper personal protective equipment, or PPE, such as gloves and safety glasses. Gloves provide insulation and protect workers from electric shock, while safety glasses protect their eyes from fine debris and other hazards. It is also essential to inspect the cable regularly for damage and repair any defects promptly. This includes checking for cuts, abrasions, and other signs of wear and tear. Any damaged cable should be repaired or replaced immediately to prevent electrical hazards. Training workers on the safe installation and use of NM cable is another critical safety measure. Workers should be trained on the proper techniques for handling, securing, and splicing NM cable, as well as the potential hazards associated with working with electricity. They should also be instructed on the importance of using PPE and following all safety procedures. Maintaining a clean and orderly work area can also help to minimize the risk of accidents. This includes keeping the work area free of clutter, debris, and other obstacles that could cause tripping or falling. It also means storing materials and equipment properly to prevent them from being damaged or causing injury. Posting warning signs and barricades around temporary wiring areas is another important safety measure. Warning signs alert workers to the presence of electrical hazards, while barricades prevent unauthorized access to these areas. This helps to ensure that only qualified personnel are working with the temporary wiring system. To recap, the safe and proper installation of NM cable in temporary electrical systems on construction sites requires careful attention to detail and adherence to the NEC requirements. By following these guidelines, contractors and workers can minimize the risk of electrical hazards and ensure the safety of everyone on the construction site. The NEC provides specific requirements for temporary wiring installations to ensure the safety of workers and prevent electrical hazards. Understanding and adhering to these requirements is essential for maintaining a safe working environment. NM cable is generally not permitted for temporary electrical systems in Type 1 or Type 2 structures due to their fire-resistant construction. The NEC permits the use of NM cable in multifamily dwellings and other structures of Types 3, 4, and 5 construction. NM cable must be protected from physical damage on construction sites due to the various hazards present. Methods for protecting NM cable include securing it with approved cable ties, straps, or hangers, avoiding excessive bending or pulling, using metal plates or other protective covers in vulnerable areas, and elevating the cable above ground level. While NEC Section 334.30 does not specifically apply to temporary NM cable installations, its principles can be applied to ensure adequate support and prevent damage. Recommended support intervals of approximately 4.5 feet to 10 feet are reasonable for temporary installations. The NEC permits splices without boxes on construction sites for multi-conductor cord or cable assemblies, provided that grounding continuity is maintained. The outer sheathing of the cable must be maintained after making the splice to prevent exposure of conductors. Wire nuts can be used for the splice, but additional protection, such as electrical tape or shrink tubing, should be used to secure the splice and maintain the integrity of the outer sheathing. Grounding continuity must be maintained throughout the temporary wiring system to provide a low impedance path for fault current. General safety measures are crucial for ensuring the safety of workers on construction sites. These measures include using proper personal protective equipment, inspecting the cable regularly for damage and repairing any defects promptly, training workers on the safe installation and use of NM cable, maintaining a clean and orderly work area, and posting warning signs and barricades around temporary wiring areas. Remember, the safe and proper installation of NM cable in temporary electrical systems on construction sites requires careful attention to detail and adherence to the NEC requirements. By following these guidelines, contractors and workers can minimize the risk of electrical hazards and ensure the safety of everyone on the construction site. Now let's delve deeper into some specific aspects of NM cable installation and safety on construction sites. First, consider the selection of appropriate NM cable for temporary wiring. While NM cable is commonly used, it's important to choose the right type and size for the intended application. The ampacity of the cable must be sufficient to carry the expected load, and the cable must be suitable for the environmental conditions present on the construction site. For example, if the cable is exposed to moisture or corrosive substances, a type of NM cable that is specifically designed for those conditions should be used. Secondly, let's talk about proper grounding technique. Grounding is a critical aspect of electrical safety, and it's especially important in temporary wiring systems. The grounding conductor must be properly connected to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding conductor must be appropriate for the size of the circuit conductors, and all connections must be made securely to ensure a low impedance path for fault current. Thirdly, consider the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to detect ground faults and interrupt the circuit before a person can be injured. The NEC requires the use of GFCIs in certain temporary wiring applications, such as in wet locations or where equipment is used by personnel. GFCIs can provide an additional layer of protection against electric shock, and they should be used whenever possible. Fourthly, let's discuss the importance of regular inspections and maintenance. Temporary wiring systems are often subjected to harsh conditions on construction sites, and they can be damaged by equipment, materials, or weather. Regular inspection should be conducted to identify any potential hazards, such as damaged cable, loose connections, or exposed conductors. Any defects should be repaired promptly to prevent electrical accidents. Fifthly, consider the coordination of temporary wiring with other trades. Construction sites are often crowded with workers from different trades, and it's important to coordinate the installation and maintenance of temporary wiring with the activities of other trades. This can help to prevent damage to the wiring and ensure that it doesn't interfere with the work of other trades. For example, temporary wiring should be installed in a way that doesn't block access to equipment or interfere with the movement of materials. Sixthly, let's discuss the removal of temporary wiring. When temporary wiring is no longer needed, it should be removed promptly and safely. The removal process should be coordinated with the electrician or electrical contractor, and all wiring should be disconnected and removed in accordance with the NEC requirement. Any holes or openings that are left behind should be properly sealed to prevent water damage or other hazards. Furthermore, always remember that electrical safety is a shared responsibility. Everyone on the construction site has a role to play in ensuring that the temporary wiring system is safe and properly maintained. By following the NEC requirements, using proper installation techniques, and being vigilant about potential hazards, we can create a safer working environment for everyone. In conclusion, the use of NM cable in temporary electrical systems on construction sites requires careful planning, proper installation, and ongoing maintenance. By following the guidelines outlined in the NEC and taking the necessary safety precautions, contractors and workers can minimize the risk of electrical hazards and ensure the safety of everyone on the construction site. It is essential to remember that temporary wiring is not a permanent solution and should be removed as soon as it is no longer needed. This helps to prevent the system from deteriorating and becoming a safety hazard. Additionally, consider the use of alternative wiring methods for temporary power distribution. While NM cable is commonly used, Other options, such as portable power cables or flexible metal conduit, may be more suitable for certain applications. These alternative wiring methods can provide better protection against physical damage and environmental conditions. Choice of wiring method should be based on the specific requirements of the construction site and the nature of the work being performed. Finally, stay informed about changes to the NEC and other relevant standards. The electrical code is constantly evolving, and it's important to stay up to date on the latest requirements. This can be achieved by attending training courses, reading industry publications, and consulting with electrical experts. By staying informed, contractors and workers can ensure that they are using the safest and most effective methods for temporary wiring installations.